What if I told you that you could analyze the entire surface of the earth from glaciers in Pakistan to forests in the Amazon using just a web browser and a few lines of code? No expensive software, no massive downloads, no supercomputer needed. That's exactly what Google Earth Engine lets you do. And in this video, I'm going to take you from absolute zero to writing real working codes that analyze satellite data like a geospatial scientist. This is Google Earth Engine Beginner's Cookbook. So let's cook. Before we write a single line of code, you need to understand why Google Earth Engine is such a big deal. We have few reasons for that. The first reason is it's a cloud-based. This means that Google server do all the heavy computations. You are not downloading terabytes of satellite imagery to your laptop. You are sending instruction to Google and they are sending you back. Second, it has a massive archive. We are talking decades of satellite data from Landsat, MODIS, Sentinel, and hundreds of other data sources, all ready to use right now for free. We also have a third reason for this is it's really fast. Operation that would take days on a normal computer takes seconds on Earth Engine. This is why researchers, governments, scientists around the world use it to monitor climate change, track deforestation, map forests, and study glaciers. All right, before we start coding here from very scratch, let me tell you about some of the data sets that we use in Google Earth Engine that we use in GIS. So the first one is the vector data. Vector data represent a real world object using coordinates, longitudes, and latitudes. The simplest form is the point, just a pair of coordinates. Think, now just think that the location of a weather station, a drop box, or a glacier measurement size. Then you have lines, a series of connected points, and finally polygon, a series of points that close off to define an entire area. For example, country boundaries, city outlines, a glacier's extent, all polygons. Then we have raster data. Raster data work completely different instead of coordinates. It divides the earth into a grid of cells like pixels in a photo, and each cell holds a value. That value could be temperature, elevation, vegetation density, or the reflectance of sunlight in a specific wavelength. And in the middle is the map. This is where your results will appear. And in the right, you have console. The console and task panel. The console is where printed output appears. Task is where your exports will be queued. Here, all your exports will be here. Up top, a search bar. Here is the search bar where you can define dataset from Google Earth Engine data catalog. This is actually our data catalog, so we can search any type of data over there. Let me search Landsat 8, and when I enter it, all of these datasets will appear. And when I open this, I can see all the minor explanations of the data. Like we have bands, and band 2 is blue, band 3 is green. We have image properties, we have terms of use, we have description, what data is and what will it do, but it have everything it will. Let's learn the three most fundamental operations in Google Earth Engine. Now here we are starting our coding, and this is the first step to write the code. So let's code here. In Earth Engine, we wrap our data inside special container objects called EE objects so that Google server can process them. For example, we define var variable, and here you can write the variable name equals to EE dot container, and here we define the type, and inside it we have a value. So this is how we define the variable. That EE dot prefix. This EE dot prefix is Google Earth Engine's signature. You'll see it everywhere, wherever you wanna work. Like in, for example, if you wanna work in Google Colab, if you wanna work in any other uh, coding platform to use Google Earth Engine, you're gonna use this container. So centering on the map, like zoom, we have a function that is called as a map dot set center. Here we define the longitudes. For example, it's 32 point. Here we define the longitudes, and we have latitudes, and then we have zoom level. The zoom level is from 0 to 20, which zooms into the street level. I usually use 8 or 9 for regional studies and the city level studies. This is our second point. The third point is printing to the console. Like whatever we are writing there, it appears in the console. And how it will appear? Print, and here you can ask variable name. For example, I am saying the variable here is my data. You can say here my data, and when you run it, here is the error because we don't have value here, but you can call it like that. This is your best friend for debugging. Whenever you want to inspect what's inside a variable, print it. Just remember, Earth Engine won't let you print more than 5,000 elements at once. And then we have the most important task, that is map.add layer, how we add our processing layers in the map. We have a proper method for this, that is map.add layer, and here is the variable name that have all the layers. This is how your data becomes visual in the map. You will use this constantly. So now let's move toward the Earth Engine data types. Earth Engine has its own version of common data types. Let me run through them quickly. We have strings, that var str is equals to ee dot. Let me say this, hello world, and you run it, and let me print it. You can see hello world here. You can write anything here. This is how strings gonna work. Then we define a number, that is var num. Number 5, and let's print it. We have hello world, we have 5. So let's see how arrays work in Google Earth Engine. We will define that we are going to use array. and then gonna define array. Then we print array. We will call it by its name. Run, and now we have array. Uh, so this is how we call them, we print them, and we use these different types of data. Now these basic types are useful, but the real power of Earth Engine comes from its special data types. These 5 are the ones you will work with constantly. The first one is EE dot geometry. Shapes and coordinates. In Google Earth Engine, in GIS, we have to deal with the GIS data, with the points, lines, and polygons. For that, we need geometry, and geometry here is shapes and coordinates. The second one is EE dot feature, a geometry plus its properties in the Google Earth Engine. Next, we have EE feature collection, a group of features. Like, we are not using one feature at a time, we are using multiple features. So here it how it works. Then we have EE dot image, a single raster image with different bands. Then we have another function that is EE dot image collection, a stack of images over times. Okay, geometries are how you define locations of the shapes in Earth Engine. Let's create few shapes in the Google Earth Engine. This will let you know how shapes work in Google Earth Engine. So let's say we are defining a point that is EE dot geometry. So here is a point, and we're going to create. Now we have a rectangle here. You can also define the line strings, multi-points, multi-polygons, and linear rings. The pattern is always the same. Pass in the coordinate pairs, and Earth Engine build the geometry. Okay, so here one more important thing for you to know, that in Google Earth Engine, all distance measures default to meters. So when you see a number like 50,000 in a buffer operation, that's 50 kilometers. Okay. Now let's put geometries to work with the real example, using counties USA from a public dataset on Earth Engine. So for this, let's remove this code for first. You can practice all of this code with me. I'll provide all of that code in the comment section or maybe in the description, so you can code with me too. So first we have map dot. And we will define it zoom level 8. Here is a practical example what we learned before. It's the longitudes, latitudes, and we have zoom level. Then we'll define the country data, that is, we will define it in the form of variables. Notice that string in quotes, that string, that's the dataset ID from the Earth Engine data catalog. You can search from any dataset directly in the code editor's search bar. Now let's apply the filter just to our counties. We will again define the variable. Sorry, we're gonna use filter here. Okay, so let's see what's the problem here. We will talk more about filter soon, but basically we are saying give me only the feature where the state code equals 09, which is our study area. Now let's dissolve all the counties into one shape using union. So we'll define another variable. And create a circular area around the first county centroid. Run it and see if there is any error. It has zoomed into my study area. Now let's add everything to the map. We will use same function map.add layer. We will first add county connects that I dissolve. This one you can copy it from here and just paste it here. And we're going to find some colors over there. red. Okay, here is some intersection, the overlapping area between two geometries. Here is the intersection. We can also apply the union here. We can also apply intersection. We can also apply the difference function. And finally, we can calculate the geometry statistics. Here you can see our red and the yellow bar, the dissolved and the circle and the dissolved. So these are basically our polygonal work that we have created.